Hello, and welcome to the first in a series of Raspberry Pi tricks and tips videos. This first video is going to look at the Raspberry Pi router. This stems from an idea my colleague Andrew Smith and I had when we were travelling back from Cardiff and Vale College, I believe, on a train. We thought to ourselves, routers are expensive, they're noisy, they take up a lot of room. Raspberry Pis are very inexpensive, they're completely silent, and they don't take up very much room at all. Is there a way in which we can use Raspberry Pis as routers? Well, of course there is. There's plenty of software around that can allow this to happen. So what we're going to do is we're going to build a Raspberry Pi router. In fact, we can go further than this. We can make an entire network in a box consisting of multiple Raspberry Pi routers. I'm your instructor, Kevin Large, and I will lead you through that process. Step 1, we need to do a headless Raspbian installation. In other words, we don't want to have to connect a keyboard and a monitor and a mouse to do this. What we're going to do is we're going to install Raspbian on the secure digital card, and we don't need the keyboard, mouse and video to do this. So let's see how this works. Okay, well, the first thing you need to do, of course, is to obtain the Raspbian image. So where do we obtain the Raspbian image from? Simple thing to do. We'll go to Chrome and we'll just tap in Raspbian. And we'll see if we can find the latest Raspbian image. Okay, so we'll download Raspbian from raspberrypi.org, downloads Raspbian, and on here you will see we've got the latest version, which is Buster. We've got a desktop with recommended software, quite a big image, a desktop without the recommended software, somewhat smaller. We won't use either of those. What we will use instead is we will use the Raspbian Buster Lite image. This is a tiny image in comparison. We only need command line access. After all, this is going to be a router. So I would go to download zip and simply download that file. As I'm streaming, I've done this earlier just in case it was a bit of a slow download. Once you've downloaded the file, what you will get is you will get a file with this file name, 2019-0710 Raspbian Buster Lite.zip. Now you can unzip this file. So we'll do that. You see it's still a reasonable size, this image, the amount of time it takes for the Windows machine to unzip it. And then what we'll do is we'll actually burn this image to an SD card. While that's unzipping, what we shall do is I'm going to switch cameras, so as we're looking down at the components that we require. So first things first, we'll need a Raspberry Pi. Now in this particular case I'll be using a Raspberry Pi 3 B+, although you can use other types of Raspberry Pis. Obviously this isn't the very latest version, the 4 is out now. We're recording this video on Friday the 6th of September 2019. You can see the wireless chip with the little Raspberry logo on top of it on here, because these have built-in wireless and Bluetooth. It's a lovely little system. There's only one thing better than having a Raspberry Pi, and that's to have several Raspberry Pis. So ideally speaking, you can do an awful lot with 3 routers, you can do an awful lot with 3 Raspberry Pis. You need some form of power supply. You could use Raspberry Pi's own power supply, although I find these are rather useful. These are little USB charging hubs. This is a 40-watt charging hub, could easily power 2 Pis, probably 3. There's a 60-watt version of this. This has 5 ports, the 60-watt version has 6 ports. Very useful for powering multiple Raspberry Pis. You'll need a cable, of course, to connect them together. What I will actually do is I'll run these off of my 10-port charging hub, 10-port version of this, which actually has a switch built on the back, so it's even more useful. You will need, of course, storage in order to put the operating system on. So I'm going to use a 16 gigabyte compact secure digital memory card together with this adapter, and I'll show you very quickly how we set that up. So 1, 2, 3 Raspberry Pis, charger, cable, optionally nice little switch, nice little 8-port switch. You can literally build a complete network in a box. In fact, is one I made earlier. So here is a network in a box, and you'll see it consists of 1, 2, 3 Raspberry Pis, the charging hub. This is the 60 watt version. This will easily power those 3 Raspberry Pis. I've used quite thick, high quality cables so as we don't get a voltage drop across the cable, which would cause the Pis to have a little bit of an issue with low voltage. Got the 8-port switch along the bottom here. This switch can do VLANs as well, so nice useful bit of kit. Got a couple of magnets holding it on at the back there. This is a high-speed steel rod. Quite a nice little way of just knocking up a little cluster quickly. So there is a network in a box without the box. Okay, so the Raspbian image should have downloaded by now. We'll switch back to have a little look. Yep, Raspbian image downloaded, extracted. You'll see that we have a file name now with .img on the end, and we can easily burn this directly to a card. So I'll take the card out of its packaging. There we go, card out of its packaging now. So we've got the SD card, micro SD card adapter. Got the micro SD card itself, little 16 gig. What make is this one? SanDisk. Nice cards. We'll pop that into the adapter, and then we will go to the laptop. This laptop actually has a slot in the side of it where I can directly put the SD card. You might need to use some form of adapter, perhaps a USB to micro SD or SD card adapter. What I'm going to do is I'm going to gently pop the card into the slot. The laptop should now see that card. Let's have a little look if it's done that. It has. So now looking at the laptop, you can see we've got SDHC, Secure Digital High Capacity, coming up as drive D. This is good. On the desktop, we've got our Raspbian images, the zipped one, the unzipped one. Inside the unzipped folder there is our image. This is what we'll use to burn the operating system. Now you can use many pieces of software to do this. The one I've found that's particularly useful is Belenia. Let's see if I can find it like this. Let's have a little look. Belenia Etcher. I imagine many people will be quite familiar with Belenia Etcher. Okay. Now it's recognised that we've got an SDHC card in there. It's giving the size as 15.93 gigabytes due to formatting, low-level formatting, etc. It's asking me to select the image, so I'll select the image which is on my desktop, Raspbian images folder, the unzip folder. There it is. Okay, and then it's just a simple case of hitting flash. Okay, I think I know why it did that. Okay. What I'm actually doing is I'm recording these videos on a Linux machine, but I know that most people at home don't actually use Linux machines as much as I do, that's for sure. So I've actually got a remote access to a Windows machine, so as I can show you this operating in Windows. And what happened there was it was just simply when I needed to flash the disk, the Windows user authentication control popped up, which temporarily stopped the remote desktop connection. I'm actually using a piece of software called AnyDesk to do this. Absolutely wonderful piece of software, free for personal use, and I would recommend that. It's very much like TeamViewer, although I'd say probably even faster. Wonderful piece of software for remote access in machines. You can see that Etcher is now flashing the disk. What it will do is it will flash the disk and then it will verify the disk. And once that's done, there's a couple of changes that we need to make to a couple of files in order to make sure that we can remotely access the Raspberry Pi across the wireless using what's known as SSH, or the Secure Shell Protocol. Okay, we're 9 minutes 50 seconds into the video. I want to try to keep this around about 15-16 minutes if at all possible. what we'll do is we'll try to keep most of the videos reasonably short. The next step after this video, which is installing the operating system image, will be to install what's known as FRR, or free range routing, which is our software which will turn the Raspberry Pi into a very powerful router. A router that's capable of doing static routes, RIP for IPv4 and IPv6, OSPF for IPv4 and IPv6, even EIGRP. Now that that's been open sourced, it does have basic EIGRP capability. It's quite amazing to see a Raspberry Pi forming an EIGRP neighbour with a Cisco router. That's something you wouldn't have expected to see some time ago. It'll do BGP, and it'll do very sophisticated BGP as well. In fact, technically you could probably just about teach the routing section of the CCNA just using Raspberry Pis. There's an interesting thought. Now you can see that the compact flash card is being validated. Once that's done, we have the operating system image on the compact flash card, which takes the place, of course, of a hard drive on the Raspberry Pi. Nice thing with the compact flash card, it's like an SSD drive, no moving parts, nothing to wear out, so we're good to go. There we are. So do we want to flash another one? No, so we can shut Etcher. I'm going to open up the Windows Explorer. I'm going to take the card out, pop the card back in again, because currently I don't see the file system on there. Now what Etcher tends to do is it often ejects the card, logically ejects the card, so you wouldn't see the file system. So it's very easy, just pop the card out in its holder and pop the card back in again. And now you can see that we have two partitions on that SD card, boot partition D and the root partition E. Now we do need to make some changes in order to do a headless installation, because I don't want to go off and get a keyboard and a mouse and a monitor in order to install this. So what I'm going to do is I'm going to go into the boot drive and I'm going to do something a little bit crafty. I'm going to run Notepad, and we're going to enable SSH, and this is how we do it. Simply run Notepad and put one space in Notepad. That's it, that's all you need, just so as there's something there, one space, all you require. Then go to File, Save As. Very important, drop down box, do not select text documents, .txt, select all files. Okay, and then what you need to do is you need to create a file just simply called SSH. Okay, and pop that in the boot partition, and Windows can read the boot partition on a Raspbian SD card. So we'll go to the boot partition and we'll put a file with SSH and no extension after it, no .txt, on the boot partition. Save. Okay. Now you'll notice sometimes Windows is a bit of a pain in the arse. It still puts the TXT on the end. That's no problem. What we can do is you've got to get rid of that extension. So we'll right click, rename, and we'll just remove the TXT. It's very important to do that. Yes, we do want to do that. Okay, so when the Raspberry Pi boots up and it notices that there's a file in the boot partition called SSH, what it will do is it will actually enable SSH on the system for you, which is rather nice. SSH, being the secure shell, will allow us to remotely access the computer. Now there's another thing that we need to do, because currently we need to set up the wireless. So again, we use our old friend Notepad. I don't think we're going to get this under 15 minutes, but hopefully we'll get it around about 20. And in Notepad we need to put some information. Let's have a little look. Now I saved this on the desktop just to play it safe, so as I could speed things up. The information we need to put in is, there we go, country equals GB. Obviously change it for your country of choice. You need to use the proper country code here. So US for the United States, GB for Great Britain, DE for Germany, and the rest of the information can stay pretty much as it is. I will actually change the network and the SSID, so I'm going to copy that and bring up my other Notepad window, and I will actually put in here, because I want to do this for real. I change my SSID and my password quite regularly, so I don't really mind putting in my real SSID and password. That's it. So my network name is data and my password is Sir Isaac Newton. Spelt wrong. Sir Isaac Newton. There we go. So let's do a double check. We got the correct country code, a wireless name, and the correct password, and this should actually connect to my network. Now what we need to do now is we need to file, save as, and as again, loser.txt, and this needs to be saved with a very specific name. It needs to be saved as WPA underscore supplicant. Careful with the spelling. Double P LICANT supplicant.conf. Now it shouldn't put text under this after this because we've got .conf on here, and that again needs to be saved in that boot directory. Right, all being well, that will get Air Wireless working, and the SSH just there will actually enable SSH. So WPA supplicant.conf, looking good. I can open that to double check. Yeah, that all looks good. And SSH, it probably wouldn't know how to open that because it doesn't have an extension on it. So we can open it with Notepad, and there's nothing in there apart from space. And that's all you need to do. And this will allow us to pop that card into the Raspberry Pi. So I'm now going to close that. Okay, and I will eject it. And it's quite important to eject it in this case because you've written to it. So this will actually hopefully close off and make absolutely certain that it's correctly written to. Right, so now the plan is we can take the card out of the computer, and we should be able to drop the card in the Raspberry Pi. So I'm going to select a Raspberry Pi, take the original card out. It's a 32 gig card. We'll pop in a little 16 gig card that I've just written. So that goes in. Be very careful to make sure that you've got the gold pins facing in the correct direction down toward the board. That's ready to go. Don't need to plug a monitor in. All we should need to do now is to plug power in. So I'm going to take the power cable, plug the power cable into the Raspberry Pi. Hold on. That's the wrong type of cable, believe it or not. Let's borrow one of these. So have a little look. Just noticed that when I was looking at that cable, it's not actually a micro USB cable. I think it's off of a external hard drive. Those little Velcro ties are very good. So there we go. Let's pop that into the power socket, and then what we shall do is we'll plug that into, there we go, yeah, nice 60 watt, capable of running probably 5 Raspberry Pis, that one. USB charging hub. The Pi is now booting up. The thing is, I have absolutely no idea what IP address is going to be on that Pi. So what we will do is we'll run a piece of software on the laptop called Angry IP Scanner. Nice one to show your students. And we'll see if we can find the Pi. I'm going to scan from 192.168.50.1. 50.1 up to 192.168.50.251. Shouldn't be anywhere outside that range. This will find all of the systems that are live on my network at the moment. So 50.68, that's actually the little Windows laptop itself. My goodness me, I never realized there were quite so many systems running on the computer at the moment. Oh, okay, so close that. These N1.locals, N5.locals, I'm using those to power the webcams that I'm using to record this video. It should come up purely with the hostname of Raspberry Pi.local, and that looks like that's the one to me. So Raspberry Pi.local is on 5066. So it would look like those two files that we wrote to the boot directory have done their job. What I'm going to do now is I'm going to load up Putty, which is a free SSH client, putty.exe, and we'll tap in, what was that, 5066. Let's see if we can actually get into the Raspberry Pi. 50.66. Haha! Okay, there's the asymmetric key exchange going on there. I think it uses something called Diffie-Hellman in this case. Very, very strong encryption. I need to accept that key. We can log in as Pi, which is the default user, and the default password is Raspberry with a capital R, and we should, oh, okay, R-A-S-P-B-E-R-R-Y. Okay. Let's try it without the capital then. I just sworn it was with a capital. No, it's I've installed Raspbian on hundreds of Raspberry Pis, and yet the password has it's all lowercase, it doesn't have a capital R. That threw me for a moment. Okay, that's the fun of doing live videos. So, as you can see, we're now in the system, and we didn't need to use a keyboard, mouse or monitor connected to the Raspberry Pi. The Raspberry Pi is sitting there quite happily, powered away, fully installed, ready to go. And now while we're here, just very quickly, what I will do is I'll show you a couple of little tricks. Alright, Control L clears the screen. What we will do is we'll do a sudo su. Okay, and we'll do a cd, change directory back to our user's home directory, so we should be in the root directory /root. We are. Control L again clears the screen. And what I'm going to do is I'm going to change the host name on this one, and I'll show you a quick way of doing that. So we can say nano, which is a text editor, etc folder, the hosts file. Look in the host file, we can see the default host name on the line that starts 127.0.1.1. We'll get rid of that, and I will call this N3. I was tempted to call it R3, but you can make a Raspberry Pi into a router, you can make it into a wireless access point, you can make it into a telephone control system, you could even make it into a switch, an SDN switch. So I'm going to call it N3 for node 3, and then we'll use Control O, and then Enter, and Control X. Control O saves the file, Enter, because we want to keep the normal host name, etc hosts, normal file name, etc hosts, and Control X exits. There's one more thing I need to do. Nano etc host name. So change that file, because in there we can still see the old file name. So N3. That's better. Notice something interesting. I don't know whether it's to do with the remote control software, but sometimes when you hit the space bar, it doesn't work. I have to put the caps lock on to get the capitals. That's probably why I was having a problem with the password, to be fair. N3, Control O, Enter, Control X. Excellent. You can type sync. You don't really need to, but that's useful for syncing anything in memory back to the permanent storage. And then what we can do is we can do a sys ctl reboot. You'll notice the remote side closed its network connection because the Raspberry Pi is now rebooting. There is the Raspberry Pi, and it doesn't take very long at all for that to reboot. You might just possibly see the little green light flashing away like crazy. That will be it reloading back up again. It's probably done it already, so we'll switch back. Rather than have to type in where we want to go into PuTTY again, I can just right click and restart session, and there we go. We'll log in as Pi, and default password Raspberry, lowercase. You'll see the host name has now changed to N3. Really, we should change that default password. Here's something a little interesting. If you try to change the password as the Pi user, it will ask you for the current password, Raspberry, and then the new password. And if I tried putting QWERTY in, something really simple, and retype, it will say bad password's too simple. It won't accept it. Okay, so what I'm going to do, I'm just going to hit the enter key a few times to get rid of that. As a normal user, it won't let you change your password to something very simple. However, there's a way around that, of course. With Linux, there's always a way around things. We'll become the root user, sudo su. We are now, well, who are we? I'll type who am I, and it will tell me you're root, the Linux version of the administrator. And as that user, we can do anything. So password for the Pi user. Notice I put Pi on the end because this is the password of the Pi user. Doesn't even bother asking me what the current password is. I can now type in QWERTY, top 6 characters on the keyboard, QWERTY, and it just updates it for me. Okay. Being as you're accessing a Pi remotely, it's probably a good idea to change the default passwords, although I wouldn't change them to something as simple as QWERTY, of course. Okay, so this is good. All ready to go. The next thing you would probably want to do is to do an apt update. What an apt update does is it goes off and it scans the repository. It pulls a update file which has all the latest versions of software, so it's effectively like a text file with all the latest versions of the software and where it needs to go to get them. It doesn't actually update anything doing apt update. It just pulls the latest repository software list effectively. So it's reading the package list now, and once you've done an apt update, at that point if you install anything or update anything, it will be completely up to date as of when you did that update. So if you leave this Pi for a few weeks, you definitely want to run apt update, but you don't want to run it several times a day because that's a bit pointless. So there's 14 new packages that can be updated. I'll hit the up arrow to put the previous command back in, and I'll put in upgrade, and what that'll do is that will actually go off and it will now pull those new packages. It tells me what it's going to upgrade. Yeah, it doesn't look too bad, so all I can do is I'll hit yes and off it goes, and it will now upgrade that software. Isn't that a nice way to install packages on an operating system? Okay, we did slightly overdo it there. I was hoping we could keep that down to about 15 to 20 minutes. No hope. It's almost 30 minutes, but I hope you found that useful. That's how you go about installing the Raspbian operating system on a Raspberry Pi without even needing to plug a keyboard, mouse or monitor into the Raspberry Pi. That's step one. So we now have a Raspberry Pi with Raspbian installed. It's also up to date. In the following video, in step 2, what we will do is I will lead you through the process of how to install free-range routing. Free-range routing is a wonderful piece of software, and what that will do is it will turn your Raspberry Pi into a full-blown, it's the real thing, it will turn it into a router. Now, it's quite a technical installation. If you've never used Linux before, you might end up watching it a couple of times, but you'll learn a lot while you're doing it. I know I learned a lot while I was researching how to go about doing it. Free range routing, wonderful piece of software, and what it will do is it will allow you to type in very Cisco-like commands, and they will be translated into the commands that Linux uses to run its big routing engine. Linux has a very powerful routing engine built into the operating system, and it will actually allow us to install free range routing and turn our Raspberry Pi into a router. Okay, Kev, I think that's about all we need to worry about for the moment. So that Raspberry Pi is now installed with the latest version of Raspbian Buster Lite, and in the next video we will show you how you convert that Raspberry Pi into a router. Now, of course, currently it only has one wired Ethernet port and one wireless connection. However, that's very easy to fix. What we can do is we can simply make use of something like this, USB to network adapter, or if you're getting really flash, you could use something like this, which is a USB to dual network adapter with a pass-through port in the back, so as you can put multiple network adapters together. You plug 2 of these into your Raspberry Pi, you'll have 5 Ethernet ports, which makes it a very useful router. Okay, I hope you found that useful. Call back in for the next video, step 2, where we will be turning the Raspberry Pi into a very powerful little router. Thanks very much for watching.